Hello everyone, myself Vaibhav Bengle and my group members are Tanmay Lotankar, Saad Sheikh and Aditya Panigre. We are the final year students of Vivekananda Education Society Institute of Technology and our project topic is Covid-19 Disinfectant Robot, and we have successfully completed our project under the guidance of Dr. Nandini Amannagi. Let's understand the problem statement. Right now, we are going through a very tough time. This COVID 19 pandemic has hit almost all the industry and damaged the health industry severely. The most alarming situation is many people lost their life during this pandemic. Now, there are some recently developed working robots which help in chemical sprinkling for sanitization purpose. But these robots can't be used in ICU research labs because maintaining desiccated environment is important. Moreover, these robots require some kind of human help to guide themselves, fill chemical fluid. So, we overcome this problem by developing a disinfection robot which will use UVC light instead of chemical fluid for sanitization purpose. Now it can be used in ICU research lab as it can maintain desiccated environment. The robot automatically moves and it disinfects surrounding by emitting ultraviolet light which is UVC light. We also implemented ultrasonic sensors around it which makes it capable of avoiding obstacles coming into its path. We have also provided a manual control features. So we have implemented an web app with integrated keys forward, reverse, left and right to control our robot.
Coming to the block diagram, the Raspberry Pi is primary device used in the project. It performs all the major operations such as interfacing with the motor driver and drives the wheels, interfacing with the ultrasonic sensor which are used for object avoidance, and infrared sensor for manual control. Since the infrared sensors are analog in nature, they are interfaced with Arduino, which is further interfaced with Raspberry Pi using serial communication. The circuit diagram shows all the components that are required for the project along with the interfacing. Raspberry Pi is the heart of this project and every component is directly or indirectly interfaced with it. In order to provide constant DC supplies to the Raspberry Pi in motor driver, additional circuitry such as voltage regulators and transistors are used. Coming to the implementation, we have divided our project in three modules. The first is the ultrasonic sensor modules using the LCSR04 sensors for object detection. Here to demonstrate the working of the ultrasonic sensor, we have used a piece of paper and we are placing it on the ruler in front of the sensor. As shown in the video, the ultrasonic sensor provides very accurate distance measurement. The second model is the motor driver model. We have used the L298 motor driver bridge and we have connected our two DC motors to it. The video demonstrates the ability of the robot to move in any direction forming an arc. Our robot is also capable of getting out of tight spaces by maneuvering in its position without moving forward or backward. The third model is web interfacing. As seen in the video, the right window shows a command prompt on the Raspberry Pi which records all the commands it is receiving. The left window shows the web page from which the robot is controlled using various direction buttons. Results: we have successfully implemented the autonomous and manual mode of operation for our robot. The robot is fully capable of disinfecting any room by housing an ultrasonic light on its chassis. In this video, we have implemented all the modules and the robot working in autonomous mode is shown. We have placed the robot in front of an obstacle and are powering it to demonstrate that the robot periodically checks its surrounding for any obstacles in its path. As we can see, the robot avoided the object on its left by changing the path to move towards its right. As it moves away further, it faces another obstacle and changes its course accordingly. The COVID-19 disinfection robot is a highly reliable alternative to the traditional sanitizing methods, and it allows to maintain a safe environment, at the same time lowering the overall cost and the increasing effectiveness. Thus, a robot can be used in certain environments like hospital ICUs or research labs where the environment would not be contaminated by exposure to the UVC light.
In this video, we have not demonstrated the working of our robot with UVC lamp, but it can be installed at the center of the robot chassis so it can emit the light in all directions to kill the microorganisms.